Hi everyone and welcome to my YouTube channel. So we'll be continuing our IMO past problem playlist, and in this video we'll be discussing our fifth IMO, which is IMO 1963, which was held in Poland. So unfortunately this IMO is one of the most boring IMOs because like both problem 1 and problem 4 are some boring algebraic equations. So if you're my dear friends ready to get bored with some IMO problems, then let's get started. Alright, so the problem statement goes as the following. So we need to find all real roots of this equation. Square root of x squared minus b plus 2 times square root of x squared minus 1 is equal to x. Of course, like p here is just a real parameter. So like when we solve such equations, we need to find the values of x depending on p, and furthermore we need to discuss cases for the parameter. For example, in some cases maybe for p there are no solutions, but in other cases we have some solution, and so on. Alright, so let's have a look at our equation. So as you can see, like we have some square roots here. So for sure, like one of the options that we'll be considering is squaring like both sides of equation. Of course, like this is here like our only method in order to get rid of the square root. Like we have two square roots after all. So like we need to get rid of this one and this one by simply squaring. Of course, like if we squared right now, we'll be just left with one like square root. Like this will be cancelled, this will be cancelled. Then we have 2 times this times this. So we'll be just having like one of them. And then like we'll square again, and perhaps like we'll be done with like the other stuff. Alright, so like this is simply our plan, like nothing complicated at all. So we just need like to do that. However, we need to be careful, because when you have equation like a equals b, if you square it, you will get a squared equals b squared. Alright, like of course this is like legal. However, when you get now with the solutions, like you have got the solution for a squared equals b squared, which like has two options, either a equals b or negative b. So like you should be careful. Always like the new like equation after squaring is not the same as the original one, because now like some conditions like are screwed now. That means we always need to be careful to preserve all our conditions before we like proceed. Alright, so like here for example, since we want to square like both sides, we simply need to handle the conditions. So for example, what do we have conditions here? For example, take a look at this equation. Like a square root plus 2 times square root is equal to x. We have many conditions here. First of all, like x clearly is positive, right? Like x is positive because x is like sum of two positive numbers. So simply like let's write actually our conditions. So we have x is greater than or equal to 0. This is a condition. What else do we have? Well, clearly like the numbers under the square roots should be positive. So simply x squared, for example, minus 1 is greater than or equal to 0, which means that we also have our second condition. X squared is greater than or equal to 1. Alright, what else do we have? Well, clearly we have also x squared minus b is greater than or equal to 0, which means that x squared is greater than or equal to p. Alright, do we have like any other condition? Well, no, that's enough. So now like we can simply square, like go ahead and square both sides. Alright, so let's do that. So if we square both sides, we'll be just like having here, let's do it here. We'll be having like x squared minus b plus 4 times x squared minus 4. Of course, like plus 2 times like 2, which is 4, square root of x squared minus 1 times x squared minus b, which is equal to x squared. Alright, like simply we cancel like x squared from here with x squared from there, and we simply like let's write our new equation here. We simply like can arrange such that of course we want this to be on one side and the other like to be on the other side, because we want to square again in order to get rid of this ugly square root. So like simply we'll be having the following: 4 times square root of x squared minus 1 times x squared minus b is equal to, now like if we take there, we have negative 4x squared plus b plus 4. Exactly. Let me just check. Minus b minus 4. Exactly. That's it. Alright. So now simply we have this new equation, and now like we need to square again in order to get rid of this like square root. However, as we mentioned, we always, before we square, we need to handle the conditions. So what conditions do we have here? We have already like handled these conditions, that these two dudes like here are positive. So now we need like to handle this thing is positive, right? Exactly. So we simply now need to put this condition as well. We need like this to be positive. Like in other words, we just like when we get our solution, we need to check that this is correct. X squared is less than or equal to p plus 4 over 4. Alright, so now like we have like we're done with our conditions. Now we can simply square and proceed with solving the equation. Well, now like you will tell me, okay, like how will you solve it? Like here, if you square, this will be degree 4. Like, can we solve a degree 4 equation? Well, is it though like degree 4? Take a look. X squared, x squared, x squared. Do we have any other x? Not at all. So that means actually, like this is a fake like degree 4. We can simply turn it into degree 2, right? By simply assigning a new variable. So like this trick should always like be in your mind. Shouldn't like fail to realize it. So simply now we'll just check, like put for example y is equal to x squared. Now our equation is simply 4 times square root of y minus 1 times y minus b is equal to negative 4y plus b plus 4. Alright, now we already like to square. So let's proceed. 16 times y minus 1 times y minus b is just equal to, like this thing squared. So simply if we want to square this, we'll just get that 16 y squared plus b plus 4 squared minus 8 b plus 4 times y. Alright, now it's time to expand. So like from the left hand side we'll get 16y squared, then like we'll have negative 16 times b plus 1y, then we have plus 16p. This thing is equal to 16y squared plus b squared plus 8b plus 16 minus 8py minus 32y. Alright, like let's actually write this like as 16p minus 16y. 16py minus 16. Okay, so now like let's cancel some stuff. So what can we cancel here? We can cancel this with this. Okay, now what? Now for example, like the py thing here and py thing here. Okay, it's safer like to make it like to the move it to the right hand side. So now simply we have 8 py here. What else can we do? Like okay, what about the like y's? The constant times y. So negative 16y, negative 32y. So we can get rid of these, and simply let's take it to the left hand side now. It will be here. Okay, 16y. Next we have 16p here and 8p here. So to the left it will be 8p. And finally we have a single p square here plus 16. Alright, so now like we simply need to find y. This is a linear equation in terms of y. You can easily find that. Okay. like actually I think okay, no problem. Like let's take just y, 8y, or like if you move it to the right hand side, it will be 8 times p minus 2 times y is equal to p square plus 8p, oh sorry, minus actually, plus 16. Alright, well, so what is actually p square minus 8p plus 16? This is just like p minus 4 square, right? Yep. So let's check, like write it as p minus 4 square. Alright, so finally, like we have the value of y. Of course, we need to be careful, this is not 0. So y is just actually equal to p minus 4 square over 8 times p minus 2. Alright, of course, like we're not solving it for y, remember, like we need to substitute for x. What was a? X squared. So it's simply x squared is equal to p minus 4 squared over 8 times p minus 2. Alright, now we have like our value for x squared. So now let's take a look, like do we have any condition now? Well, of course we have. Like this is positive, so this must be positive, which means that p must be greater than 2. Oh wait, did I make a mistake somewhere? Guess I made a mistake somewhere. Okay, just a second. Let's see here. Yeah, okay, like here, p minus 2. So to the left hand side, here we have 8py. Oh wait, it should be like, oh, it should be negative 2 minus p, I think. Yep, because if we move like this to the right hand side, now it will be 8 times p minus 2. So actually, like, it should be negative, right? Oops. So no problem at all. We can simply just make this 2 minus p. And hence here we need to make it 2 minus p. And hence here it should be 2 minus p. Alright, now everything is good. So now, like, we have a condition that this dude here must be positive. Okay, so that just means that we have actually p is less than or equal to, of course we don't have equality, so p must be strictly less than 2. Alright, so now we have like a condition on the parameter p. Okay, and of course now we can simply like say that the value of x is positive or negative p minus 4 over root 8 times root 2 minus p. Alright, very good. Like we found simply the solution x. So like, are we done? Well, of course no. We need like to handle lots of conditions before and some other stuff as well. So for example, now take a look at the condition number 1. We know that x is positive. Condition number 1, x is positive. Is this positive? Well, the denominator is positive, okay, but the denominator, what is p minus 4? Is it positive or negative? Well, clearly it's negative, right? Because p is less than 2, so of course it's less than 4. So that means this dude here is negative. So in order to make it positive, we should just choose the negative solution. So we actually, like, the solution is 4 minus p, right? 4 minus p should work. So simply here 4 minus p. Okay, so now like we've handled like condition number 1, and this is positive. Good. Okay, what else? This was condition 1. What about condition 2? Is x squared greater than or equal to 1? Well, we have x squared from here. We don't need like to go here. We already have x squared here. So let's just check that if this dude here was greater than 1. So let's simply write is like p minus 4 squared over 8 times 2 minus p. Is this 2 greater than or equal to 1? Well, because we know this is positive, we can multiply both sides by like the denominator, no problem. So this is actually the same here in this case as saying that, let's expand immediately, p squared minus 8p plus 16 is greater than or equal to 16 minus 8p. Alright, this is like cool. P squared is greater than or equal to 0, which is correct, of course. So exactly, like condition number 1 is good. Next, we need to handle like x squared greater than or equal to p. So let's do the same process again. We have y from here, we just or x squared, sorry. We just need to check that it's greater than or equal to y. Let's go ahead. So what was it? P minus 4 squared over 8 times 2 minus p. Is it greater than or equal to y? Well, simple also, we do the same thing exactly. P squared minus 8p plus 16 is greater than or equal to, well, here we have 16y, and then we have okay, minus 8py. Okay, so what can we do now? Oh, sorry. Why was I putting? Okay, it is p, not y. Sorry. All right. So I mean, like it was 16p minus 8p squared. Yeah, this question is really boring because like all the steps are easy. You just like need to do some calculations, and it's very easy to make some calculation mistakes. So we need to be careful. Okay. So right now we have. Okay, we just this is the same as 9p squared, and here we can make it minus 24p plus 16 is greater than or equal to 0. Well, guess what? This is just 3p, and this is squared, so it should be like negative 4 squared is greater than or equal to 0. So yes, it works. So condition number 3 is like checked. Now we just have our final condition. Does it give us any like condition on the parameter y, or it's useless as well? Oh, sorry, p. Why do I keep saying y? Okay, so now we also have x squared. We just need to check it's less than or equal to p plus 4 over 4. All right, so now what was it again? P minus 4 over 8 times 2 minus p. Is it less than or equal to p plus 4 over 4? Alright, we already have good thing that 4 cancels with 8, so we have 2. So it's actually the same as, again, because this is positive, we are multiplying by both sides. However, if we don't know that, we cannot do this. Be careful, this is very important. Okay, so now we have 2 times 2 minus p times p plus 4. This is greater than or equal to p minus 4 squared. Let's expand. Alright, so negative 2p squared, then we have negative 4p, so negative 2p, so negative 2, so negative 4p, and finally 4 times 2 times 2, so plus 16 is greater than or equal to p squared minus 8p plus 16. And now we cancel the 16, which is good. Now we have 3p squared, and we have minus, okay, 4p is less than or equal to 0. Alright, so simply that just means that p times 3p minus 4 is less than or equal to 0. So this is negative, so that means x should be between the two roots, oh sorry, p. So that means that p, okay, so here what is the root of this thing? 4 over 3. So p simply p should be between 0 and 4 over 3. Alright, so that's good thing. Now we have a condition on p, parameter p. And if you can see we have that p is less than 4 over 3, which is strict, more strict than the other condition, which was p is less than 2. Okay, so now like simply what do we have now? Like we've handled all the conditions. We got simply that p is between 0 and 4 over 3. That's like the condition on our parameter in order to have like solutions. If p was in this like parameter, then we already satisfy this condition. Then like we have our solution, which was like the previous one. So simply that means that the solutions like we can just write if p is between 4 over 3 and 0, then x is equal to, I think it was 4 minus p over root 8 times like 2 minus p. Else, no solution. Alright, so that's it. Finally, we're done with the boring like IMO problem 1, which was like our 5th IMO, as we said. Alright, so as a summary, like in this question, which was like simply we need to solve an equation with parameter, we always like need to be careful. First of all, like of course, like the trick in order to get rid of the square roots is simply to square both sides of equations. However, you need to be careful not to miss the conditions. You should always like put all your conditions. It's safer. Put like your conditions in an organized way, and then like square. Like you need to square another time. Also put the new conditions. Don't like forget. Don't skip any of them. Ignore any of them. Always put your conditions like in a box, for example, and keep like squaring until like you get rid of all your square roots. And of course, we always have this simple standard trick. Whenever you have like x squared everywhere, just like set a variable for that. Even if you have x cubed like everywhere, you just like put a variable for that, and now like you decrease your like degree, for example. So it's, that like was simply the IMO problem 1 of the 5th IMO. Like as we saw, it was like easy question, just like boring like discussion, and we should be always careful not to do calculation mistakes or forget any conditions. Alright, so I hope you guys enjoyed this question or this like video. Please like, share and subscribe to this channel, and see you guys in the next video.